Okay, we are on page 5, and page 5 continues with the last problem on page 4, which asks you to predict a formula for the derivative of f of x for the form x to the n. And remember we did this in our investigation. Basically we had that the derivative of x squared was 2x, and the derivative of x cubed was 3x squared. And I asked you what the derivative of x to the fourth would be, and you said it would be 4x cubed, which is correct. Now, what if it was x to the n? Well, look at the rule you were using here. You were taking the 4 here, and you were copying it down here, and then you were reducing the 4 by 1 there. So you would take the n, you would put it up front, and then you have the x here, and the n would be reduced by 1. So basically your rule, or your formula would be that, okay? So now let's find the derivative of the function f from first principles, which means we make the little triangle, given that f of x is, and they give us a couple examples here. So let's do the first one. So we have a triangle, and again, the x coordinates are x and x plus h. And then this bottom coordinate would be, we're going to plug in x in the expression, so we're going to have 2x plus 5. And then the top one is we're going to plug in x plus h in the expression, so we're going to have 2 times x plus h plus 5. Okay? And then we're going to find the slope of this. The slope is going to be the limit as h approaches 0 of, and the numerator is going to be 2x, and I'm going to multiply out here and do the distributive property. Okay, minus 2x minus 5. I have to distribute the negative sign 2, all over x plus h minus x, which of course is just h. So now on the top we have we're going to cross out the 2x's. 2x and 2x can be crossed out, right? 5 minus 5 can be crossed out. What we're left with in the end is 2h divided by h, which is just the same as 2. So you can see that for this function, the gradient at any point is 2, which, hey, guess what? It's a straight line. Straight line always has the same gradient or slope, and the gradient is the m value for mx plus c. So we can see it right there. It happens to be 2. Okay, so first principles, all that calculation just gives you what you've already known about straight lines. Okay, now we're going to do this one, which is a little bit more complicated. So again, we're going to have x and x plus h for the x side, and for the y, we're going to have, for this point here, we're going to have negative x squared plus 5x minus 3. And for this one here, we're going to have x plus h squared plus 5x plus h minus 3. Okay? And this is going to be, and then so if we're going to find this limit, it's the limit as h approaches 0. I'm going to go ahead and expand this part here in purple, all right, and I'm going to put it here. So I'm going to have negative x squared minus 2hx minus h squared plus 5x plus 5h minus 3. And then I'm going to subtract the bottom part here in red, and I'm going to go ahead and distribute the negative sign. So it's going to be negative x squared. So it'll be positive x squared, be negative 5x, and a positive 3 because I'm subtracting it, remember. And on the bottom I have x plus h minus x, which is just going to be h again. And now I'm going to try to find some common terms that I'm going to cancel out. Negative x squared cancels out with positive x squared. Negative 5x cancels out with positive 5x. And maybe that's the only thing left. Oh, and positive 3 cancels out with negative 3. So then we're going to cancel out some of these terms that are both on the top and bottom, like h. So h is on the top, h is on the bottom, so I'm going to cancel out the h on the bottom, with the h's on the top. Okay, oops, I'm having a hard time crossing that out. Okay, now I'm going to rewrite the whole thing. So I'm going to have limit as h approaches 0, as h approaches 0, of negative 2x minus h plus 5. So now if I plug in the h equals 0, I no longer get 0 over 0. I now get negative 2x plus 5, which using our prediction, if you take the derivative of negative x squared, we should get negative 2x to the first, right? Which we do. And then if we take 5x, if we take the derivative of that, we should get 5x to the 0, which we do. And then the negative 3 is negative 3x to the 0. If we take the derivative of that, the 0 is multiplied times everything. And then here we're getting negative 1. And the 0 times anything is just 0. So, in the end, it works for all of the powers. Okay, our rule that we derived up here, it works for power of 0, it works for power of 1. All right. Number 3. Again, we're going to use first principles. So we're going to draw a little triangle. And we're going to have x, and we're going to have x plus h. And here we're going to have 4 minus x, and here we're going to have 4 minus x plus h. And then so we're going to write out our equation, limit as h approaches 0. And on the numerator, we're going to have 4 minus x minus h minus a 4 minus x divided by h, because it's x plus h minus x. Okay, and so we can rewrite this as the 4's cancel out, this 4 minus x minus a minus x, and so we're left with negative h over h. Negative h over h, which is just equal to negative 1, right? Because these cancel out, you get 1, negative 1. Okay? And that makes sense, right? If you took the derivative of the 4, it's a flat line, so the gradient is 0. If you took the derivative of negative x, it's a line with slope negative 1, so the gradient is negative 1. Okay, moving on. This is a challenging one. It's a cubic function. So the limit as h approaches 0, and again, we draw a little triangle, and the bottom x values are x and x plus h. The y values, the bottom one is the function as it is. X cubed minus 2x squared plus 3, and the top one is going to be x plus h quantity cubed minus 2x plus h quantity squared plus 3. Okay, and then we're going to expand it out, so we're going to have, now you got to know the binomial theorem. So it would be, oops, I'm sorry, it's not 3x squared, it's just x cubed. And then it's 3x squared h plus 3x h squared plus h cubed. That would be the first part. And then we'd have minus 2x squared minus 4x h plus, no, minus 2h squared plus 3, and then I would subtract this other, I would subtract this expression here. So I'm going to write that one in brown. So I'm going to have minus x cubed. Oh, I'm going to write it exactly where it corresponds to. I'm going to put minus x cubed, then I'm going to put minus a minus 2x squared, which is plus 2x squared, plus 2x squared. And then the last one is plus 3. I'm going to put minus 3. So these are the three that I eliminate. And then in the denominator, of course, I have x plus h minus h, which is just, or x plus h minus x, which is just h, right? Let's see what I have left. limit as h approaches 0 of, and I'm going to put, oh, and the other thing I can do is I can eliminate some h's here, right? H eliminates there, eliminates there, eliminates there. It's h squared is left there and there. So what am I left with now? 3x squared plus 3xh plus h squared minus 4x minus 2h. Okay, and like now we can put in h, 0 in for h because there's no h in the denominator, and we're just going to eliminate anything with an h in it because now we put a 0 in, it cancels out. So now we end up with 3x squared minus 4x. And now we can compare this to our original function, which is this one. If we were going to take the derivative of this one, x cubed becomes 3x squared, that's right. Negative 2x squared becomes negative 2 times 2x to the first, which is negative 4x, which is, that's right. And this just becomes 0. So we can see that doing it by first principles, we're still going to get the same thing as if we use the power rule. Number 4, use first principles formula, f dash a, blah, 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 to find f dash 2 for f of x equals x cubed. Okay, so now we're going to draw our little triangle. And we're going to have, instead of x and x plus h, now we're going to have 2 and 2 plus h. And on the y side, we're just going to put 2 in for x cubed. We get 8, right? 2 cubed is 8. And the other one's going to be 2 plus h cubed. And now we're just going to do the same thing we did before. We're going to find the gradient as h approaches 0 of this little triangle here. And so we're going to have 2 cubed plus 3 times 2 squared h plus 3 times 2 times h squared plus h cubed. And then I'm going to subtract off 8. And that's all over x plus h minus, or 2 plus h minus 2, which is just going to give me h. Now let's simplify this. Okay, so 2 cubed minus 8 is just 0. And everything else has an h in it, which we can cancel. So we'll cancel this h with that h, and with that h, and with that h. And we're left with 3 times 8, which is 24. And we're going to have 2 times 3, which is 6h, and h squared. Okay, and then we can see if we put h equals 0 in for the h's, that will eliminate this and this, and we're left with just 24. Okay, and okay, so that is the answer. So the gradient for the function x cubed at x equals 2 is 24. And let's check that. We'll take the power rule and we'll say, hey, the function, or the f dashed x for this is going to be 3x squared. Then we're going to put in x equals 2 to see what we get. And we get 12. So something's wrong here. Oh, 3 times 2 squared is not 24, it's 12. Sorry. Always good to check your work, using a different method if possible. Okay, number 5. We're almost done. Use the first principle methods formula to find the gradient of the tangent 2. Okay, so we are going to find the, we're going to do the same thing as we just did right before. Instead of having x, we're going to have negative 2 and negative 2 plus h. And here we're going to have 3 times 2 plus 5, or 3 times negative 2 plus 5, which is negative 6 plus 5, which is negative 1. And then for this point here, we're going to have negative, or we're going to have 3 negative 2 plus h plus 5 for that point. Okay, and so now we're going to write out the limit of the function as h approaches 0. the first, I'm just going to expand this out, okay? So I'm going to put negative 6 plus 3h plus 5. And then I'm going to subtract off a negative 1, so that's plus 1. Okay? And then in the denominator, I put negative 2 plus h minus a negative 2, which is just going to give me h. And now I'm going to have negative 6 plus 5 plus 1. Negative 6 plus 5 plus 1 becomes 0, and so we're left with 3h divided by h, which is just 3. So our answer is 3, which makes sense, right? This is a straight line. The gradient of a straight line is always 3. Next one, x squared plus 3x minus 4. So let's draw our triangle again at x equals 3. So we're going to have 3 here. We'll have 3 plus h here. And then here we'll have 3 squared plus 3x plus minus 4 with 3 plugged in. We'll have 3 squared is 9. And then 3 plus 3 is also 9. And then minus 4. So 18 minus 4, which is 14. And then if we put an h and x, 3 plus h in there instead, we'll have 3 plus h squared plus, we'll have 3 plus h squared plus 3 times 3 plus h minus 4. And then so now we'll write out the equation. Limit as h approaches 0 of, and then we'll expand this this part out here. We'll expand this out. So we'll get 3 squared, which is 9, plus 2 times 3 times h, which is 6h, plus h squared, and then we'll have plus 9 plus 3h minus 4. And then we subtract out this value, which is minus 14. And then in the denominator, we have 3 plus h minus 3, which would just leave you h. Okay, so let's cancel out some of the numbers we can. So like 9 plus 9 minus 4 minus 14 is 0. And then we're going to cancel out our h's. So we cancel out that h with that h with that h with that h. And we are left with the limit as h approaches 0 of 6 plus h plus 3 and over 1. And so that would just be 6 plus 0 plus 3, which is 9. And then now let's check to see if that works out. If we use the power rule, then this derivative would be 2x plus 3, and we're plugging in x equals 3. If we put 3 in there, we'll have 2 times 3 is 6, plus 3 equals 9. So yeah, it worked out. Okay. Finally, the last one. Y equals x cubed minus 3x. Find dy dx from first principles. Hence, find the positions on the graph at which the tangent has a 0 gradient. Okay. I think that you guys are probably getting tired of doing this formula, so I'm just going to draw the triangle, and then after that, if you want to, you can do it all the way to the end on your own. So it would be x plus h here, and then the y values would be x cubed minus 3x, and this one would be x plus h cubed minus 3x plus h. Okay. And then it says, find the points on the graph at which the tangent has a 0 gradient. I'm just going to cheat here. I'm going to use the power rule, and the derivative is going to be 3x squared minus 3. Okay. And then we're going to say, okay, when does this derivative equal to 0? Or when does the gradient of the tangent have a 0 gradient? And so we can just solve this equation now. So we have 3x squared, x cubed, x squared minus 3 equals 0. When is that equal to 0? Well, we're going to add 3 to both sides, and we get that. We divide 3 from both sides, we get x squared equals 1. So it would be x equals negative 1 or 1, right? These are the two x coordinates, which would give you a gradient of 0 for the graph. Okay? And that's it for this page.